Hello. Now you want to find the Laplace transform of cos 80. Okay, so the function here is cos 80. Alright, so we use the definition of the Laplace transform, giving us this integral 0 to infinity f of t e exponent minus st dt, given s is positive. Now the function we are considering here is the cos 80. So in place of f of t, we use cos 80. Okay, so now the next step is we compute this integral. All right, now ideally we do this using integration by parts. All right, but we can also use a very important fact. That is the all-less formula to do this simply. All right, so I want to use that one rather. But you can go ahead and use the integration by parts. It works out fine. All right, so I just take notes of this all-less formula, giving us cos theta plus I sine theta. Okay, this is the formula we want to use here. All right, now what I want you to take note is that cos, which is being considered here, is the real part of this formula. Okay, just as sine is the imaginary part of this formula. All right, so we want to make use of this real part. All right, so I'm going to write cos 80 as the real part of what? Just use this. The real part of the all-less formula. Now take note that here is theta, but what we are actually dealing here is 80. Okay, so that is what I have. Now I'm going to rewrite this as this and then use this to find my Laplace. All right. Okay, so now I'm going to replace the cos 80 by the real of e exponent I 80, like that. Okay, and then just as we've been doing, use the definition. So over here, my f of t is now the real part of this. All right, e minus st dt. Yeah, right. Okay, so real re here has no use here, so I can bring it out of the integral sign and then have ei80 times e to the power minus st dt. Okay, so the next step, I put these two together. I have I80 minus st dt. Okay, now I want to factor out t from this exponent. All right, and I will factor out minus sine 2 from this exponent. All right, to ensure that my integral converges. All right, so this will be minus out. I have s minus ia, and I have t outside, dt. Now the next step is to integrate this improper integral, and then we all know how to do integrate an exponential function. So you differentiate this and then you divide the result. Okay, so we have, when I do that, this is my original function. And when I differentiate this, I have minus x into bracket x minus IA, all right? I'll divide that like this. And I'll bring in my limits from 0 to infinity. Okay, now I can take my limits. So I will take the limit as t approaches what? Infinity, all right? Now when I do that, infinity comes here, this whole thing becomes e exponent minus infinity, which is 0. Okay, so this whole thing becomes what? 0. So it's going to be 0 over this. Now any 0 over any number is what? 0. So I'm going to have 0 here. All right. Now minus, now I'll take the limit as t approaches 0. Now in place of t, I'll put what? 0. Now this whole thing becomes e exponent 0. Now we all know that e exponent 0 is what? 1. Okay, so I'm going to have 1 at the numerator. Now take note that I have a minus sign here. Very important. So I'm going to have minus 1 over s minus ia. Okay, so this whole thing is going to be the real part of 1 over s minus ia. Yeah? Okay. Now the next step is to, what I want to do next is to realize the denominator of this. So I have real part of 1 over s minus ia. I want to make this part real, so I multiply both the numerator and the denominator by the conjugate of this. So this becomes re x plus ia over s squared plus a squared. Okay, now when I multiply that, I'm going to get s squared plus a squared. Remember that I will get I squared somewhere there, and then I squared is minus 1, so it makes this one plus. All right, so now I just want to draw your attention to this, that I can actually break this into 2. I can make s plus ia over s squared plus a squared. I can make this s over s squared plus a squared plus ia over s squared plus e squared. I can actually do this, all right? Now, what this is actually telling me is that I'm going to take the real part of this. And then from this is the real part, and this is the imaginary part. Okay, so this is the real part. So that is what I'm after. So what this actually means is that the Laplace of, we first wrote it this way, and then we know that this is the same as the Laplace of cos at. So this is actually s over s squared plus e squared. So when you're asked to find the Laplace of cos, all you need to do is identify your a and just put it in this function, and that's all. So let's look at just one example. Laplace of cos 3t. Now over here, my a is what? 3, so I'm going to have x over s squared plus 9. Great. Now, thank you very much. Like and then subscribe for more videos. Have a great day. Bye.